Okay, so the topic for today's discussion is routing. So once we complete the routing part, we will then switch back to firewall policies and how to configure profiles. So that will be the follow-up topic. Now, what is routing and when routing is applicable? So, as discussed in the previous class, FortiGate operates in three mode. One is the default mode or NAT mode, which is also called as routing mode. And the second thing is transparent mode and then virtual wire mode. So let me now type that down. So NAT mode, we call it as vWire mode or virtual wire mode. And then we have transparent mode. So in NAT mode, we have the by default the routing engine will be running here. So in virtual wire and transparent mode, routing is not really mandatory. Transparent mode is something that is applicable for the entire VDOM. So then for the entire VDOM, there won't be any routing happening. And in vWire mode, it's specific to the interface config pair. So we can say partial routing will be running. But in NAT mode, routing will run by default. The moment you turn on the firewall, the init daemon will spin up the ZBOS process. ZBOS will then start running the routing in the firewall. We will discuss about these daemons in detail at later part. So now, what is routing? So routing is nothing but connecting two different network segments by any L3 device. So any L3 device can behave as a router. Even our PCs can behave as a router. If it's, let's say, if I have a Linux machine, I just need to install a ZBOS process in the Linux machine, and then I can make the Linux behave as a router. So any L3 device can behave as a router here. So a router is a device that basically forwards packets between two different IP networks. So when we say two different, this is because this is the reason why, like in routers, we won't be able to configure overlapping subnets because any L3 device capable of routing will not allow us to configure overlapping subnets in the same VR or in the same device because basically their functionality is to forward packets between two different IP networks. So if I am to give a definition for routing, it's nothing but the process to determine the next hop to forward packet based on destination IP address. So this is an important thing in routing. Destination IP address. Routing will always happen. The route lookup or the process will always work based on the destination IP address, no matter what direction the traffic is flowing from. So even if it's a source to client to server or server to client, or every time the routing will always happen based on the destination IP address. Now, these are general things. Now, if I am to focus on the FortiGate specific things, FortiGate will perform routing for two types of traffic. So basically, FortiGate will perform traffic for user traffic, sorry, routing for user traffic, and also local out traffic. No, what is user traffic? So any pass-through traffic that is flowing through the firewall. So when we say pass-through, it can be any users trying to access Netflix, YouTube, anything, or if your if an user is trying to access your SAP application or SMB servers, anything, these any traffic that is traversing the firewall, that is what we call user traffic. So FortiGate will perform a routing for a traffic that is going through the firewall that is passed through, and the second is the local out traffic. Now, when we say local out traffic, these are the traffic that is generated by the firewall. For example, if I do a ping from the firewall, that is a local out traffic. Now, if the firewall if the firewall have to reach out to 40 guard servers, so that is another local out traffic. So for all these local out traffics, again, a firewall will use routing. Now there are local in traffic as well. If let's say if I am trying to access the firewall's HTTPS page or SSH, now that is a local in traffic. Any traffic that is generated by the firewall going out is a local out. So what are the contents of routing table? So what does a routing table look like and what does it have? So let's take a look at this. Let me spin up the lab. So the username for the firewall is admin and the password is test at the rate of 123 T is caps. Okay. Okay. So this is what the routing table in the firewall looks like. It is very much similar to Cisco routing table, which you see. But again, the reason being, they all are running ZebOS. So ZebOS is nothing but an open source routing engine that is being used by most of the network device providers or OEMs. So literally everyone in the market is using ZebOS. Now, how to verify if they are using ZebOS? You can run the command fnsysctlps. So this will list all the process that is running in the firewall. And here you will see the process ZebOS being started. So let's check. So we have all the OSPF and everything running here. But before OSPF, there is ZebOS. So before OSPF and BGP and all these process starting, ZebOS will start first. So ZebOS is a routing engine used by FortiGate firewall, and here is the process running. So this is very much similar to the routing table is very much similar to Cisco or other vendor devices. So basically, you will get the VRF ID, so which VRF you are in, and what kind of route we have in our routing table. So we will in today's session we will look into all these details. We will discuss what all these refers to and what kind of situations where we will see multiple routes to same destination and those things. So let's go one by one now. So basically, a routing table, this is what we refer as routing table. A routing table contains a series of entries which we refer to them as route. So each route or each entry is a indication. It indicates the next stop where it have to reach for a particular destination. For example, if I have to reach the subnet 35000/30, where should I go? It is directly connected and it is on port 5. So basically it says to reach this destination, what will be my next stop? In this case, my next stop is directly connected and that is on port 5. Now, if I am to consider the default route for an example, so in this example, so if I have to reach my default route, that is if I have to reach internet or any location, my next stop is 172.16.0.1. So this will be my next stop address. To this address, we will resolve our MAC address, destination MAC, and then we will forward the traffic out of port 2. So this is what the routing table will say. Any entry in the routing table, let me write this down. So each route is an indication to the next stop for a particular destination. So this particular destination is something very important because in later part we will discuss about how the route selection happens. So at that time you will realize the importance of particular destination because there is a way the routing table will choose a best route or which route to use. So at that time we will get to know what we mean by particular destination. So now you can have now we know that the routing lookup will happen for the destination IP address when a packet reaches a firewall. Now here comes an interesting question. So in a firewall, packets keep on coming. So let's say if I am to reach a HTTPS server, let's say abc.com, my client PC might generate 10 different packets. But does that mean a route lookup will happen for all 10 packets? Now, if the device is not maintaining a session table, in that scenario, the device have to perform route lookup for all 10 different packets. Now, this is applicable for routers. A normal L3 device, it have to perform a route lookup for all 10 packets. But a firewall being a device which maintains session, being a stateful device, it don't have to perform route lookup for all the 10 packets. It only have to perform route lookup for the first packet, and then it builds a session table, and based on the session it will forward the packet out. Now there can be scenarios where let's say now firewall receives a packet. Now firewall receives a packet, it does the route lookup, and it sorry for the typos. It does route lookup and it determines that the egress interface is, let's say, port 3. Now, subsequent packets, they all use port 3. Now, for some reason, let's say if port 3 is going down. Now, if port 3 goes down and if there is an alternate route that is going via port 4, now, and if the firewall is deciding only based on the session table, it don't know that port 3 is down and it have to switch the traffic back to port 4. In this scenario, the packet will fail. So there is a concept called dirty sessions, which basically clears the existing session table and then rebuild the session, or it will go for another session lookup, which we have to discuss in detail in a separate session. But the short answer is whenever a interface change happens on the firewall will notify or it will clear all the sessions, or it will instruct the CPU to that we have to clear all the sessions and we have to do the route lookup once again. So because of this reason, whenever one port goes down and if there is a better route or alternate route available, now firewall will go through this route lookup process once again and then rebuilds the session. Now, there are certain scenarios in which firewall will do this action. We call as session dirty action. There are certain scenarios, only in 3, 4 scenarios, firewall will do this. So we will discuss those session dirty in a later part, but the short idea is CPU will be notified that the interface has gone down and firewall have to do a session lookup to change all the traffic from one port to another port if any port fails. Sorry if this part is a bit confusing, you will get some more clarity when we go down the line. Excuse me on that. So let's come to okay. Let me start another firewall. We'll have better context here. So let's check the routing table here on the remote firewall. So I have one default route that is pointing towards port 3. Um, let me configure another route on port 4 real quick. So 35.2. So this was the issue which I faced on the first day. So wrong IP address. So let me correct port 4. So if you check the subnet mask for the subnet mask slash 30.3 is the broadcast IP address. That is the problem the other day. No, I had to change the upstream as well. So let me check. It's not responding. Edit port 6. Okay. Give me like 2 minutes. I will set this up. So 192.168.1.3. Okay. So basically this is what I wanted to show. Now, we have two static routes in the which we have configured manually. But if I check the routing table, there is only one route and that points to port 4. If I scroll back, earlier it was pointing to port 3, but now it's only pointing to port 4 and it only has one route. So where does that second route go? So we can clearly see in the GUI that I have configured two routes, but on the CLI, when we verify, we only see one route. So Rajesh has the question, what is the AD? So the AD for default route is by default 10. So that is what we see here. So now we will discuss why this behavior is happening, or why there is only one route being shown in the routing table when we have two routes configured. So let's check all those details now. Now, there can be scenario that let's say if I con let me create one more route. Let's say this goes through port 3. There can be scenarios like we will be having two different routes to the same destination. So in this scenario, how the firewall will choose the best route? How firewall will determine which route is the best? And we call this as tiebreaker scenario. So what are the parameters used to break the tie when we end up in a situation where uh, one or more routes are matching to the same destination? And we are not discussing about the ECMP here. So it's a situation where ECMP is disabled and one or two routes are pointing to the same destination. and which route to choose from it. So let's take a look at that. Now, the other day, one of you asked me to explain the one of you asked me to explain the uh, life of a packet in the firewall. So that requires a separate session, which I have planned for one day. But in short, what I have to highlight one key information here. The route lookup on the firewall happens before policy lookup. So before the traffic goes for a security policy lookup, the route lookup is performed. Now, the reason for this is to identify the egress interface. Only if we identify the egress interface, we will be able to perform a route lookup. The reason being, if you remember the five tuples, the interface is one of the tuple, and it is in absolute information we need for a policy to match. So for this reason, the route lookup will happen first, and then the policy lookup will happen. Now, let's say during a route lookup, we end up in a situation where the traffic is passing through port 3, and then we will go for a policy lookup, and then the NAT operation will happen. And now, let's say we are doing a DNAT in the traffic, and now the destination IP has changed. Now the firewall have to perform the route lookup once again. Let me write it down. So let's say we performed the route lookup and we say port 3 is the egress. Now policy lookup happens. Policy lookup happens and it's a condition, the traffic is allowed and there is a DNAT being happening on the policy. Basically, it changes the traffic from destination. Let's say the destination is 120.1.1.1 and the destination is now changed to 130.1.1.1 based on the DNAT policy. Now, after this, now the destination for the traffic has changed. So firewall will go for one more route lookup. And this time, let's say based on the routing, the port has changed to 4. And now it will, after this route lookup, it will again go for policy lookup. And then it will check if the traffic is allowed or denied. So based on the action, now the traffic will be either allowed or denied. Now, because of this reason, because the policy lookup, since the policy lookup is changing the destination IP address, now we have to do the route lookup once again and then send the traffic out. Now, if we configure the routing and policy suboptimally in the firewall because of this race condition, you will end up in a situation where firewall will not forward the traffic out, but will keep on inspecting policies and do a route lookup again and again. So when we configure a firewall policy on the firewall, the policy should be configured based on the routing action. So if your route if you must be aware about the routing in your setup, and if the routing says the traffic has to forward out of port 3, then your policy should be configured for port 3. And if it has a NAT action in it, then the NAT should be considered before configuring the policy. And NAT should be based on the routing setup. Now, in most cases, we will be uh, we will be performing source NAT when the traffic leaves from inside to outside, but only if the traffic is coming from outside to inside, or only if we are hosting a server in our network, which has to be accessed from internet, we will use DNAT. So when we use DNAT, we should know for sure behind which interface the server is present and behind which uh, on what IP we are doing the DNAT, and we have to write the policy for that. If we do if we create a situation if administratively, if we create a situation where the traffic has to go for multiple policy lookup. Now, two policy lookup is fine, it's acceptable. But if it's more than two, then you will end up in a situation where the CPU of your firewall will run high, because firewall is not doing anything special. It's doing normal packet forwarding, but still the CPU of your device will go high because the routing and policy lookup is not optimized. So this is something as an administrators we have to keep in mind. Now, since firewall is a stateful device, it maintains session table. Now, firewall will perform route lookup for uh, two sessions. For each session, I mean to say, for each session, firewall will perform two set of route lookups. So the first one is for the first packet sent by the client, and the second one is for the reply packet coming from server. So even though we have the session table built, there can be certain asymmetric routing scenarios where your return traffic can come on a completely different interface. Let's say your client to server traffic went out on port 3, and your server to client traffic can still come on port 4. We call it as asymmetric routing scenarios. So for such scenarios to be handled, firewall will perform two set of route lookups, one for the client to server and second for the server to client. Now, if there is any change in this interface or in the outgoing interface selection, then it will impact the routing table. So FortiGate will remove the particular session from the table, and then it will perform the route lookup process once again. So let's say if this changes from port 4 to port 5, now this session is not valid anymore. So firewall will remove this session table, and then it will perform these two process once again. So in a later part, we will run some debugs on the firewall to see how exactly a session is being built, and then we will also check how a session is re-evaluated. So at that time, you will get some more clarity on this part. Now, I want to share another information. So we know for the fact that FortiGate is using ZebOS. Now let's keep this in mind. Now, FortiGate uses two different tables. So when we say, we can refer them as route table, but there are two different tables being maintained by the FortiGate. The first one is we call it as RIB, which is routing information base, and the second one is FIB, that is forward information base. Now, please don't confuse these two terms with MAC and ArcCatch. They are not similar, but please don't confuse this with that. So what is routing information base? So basically, routing information base will contain all the active routes which you're learning. So all the active routes will be available in the routing information base. It can be your connected route, static route, or your dynamic route. So all those information will be available in your RIP table, that is routing info base. Now, fib on the other hand, it's a table from the perspective of kernel. So routing information is something which, as an administrator, we will understand. It's for our purpose, and forward information base is for the kernel. When we say kernel, it's for the CPU or the OS2 function. So this is something which is maintained by the FortiOS. Now, why we need these two different tables? Now, this is where the ZBOS comes in. Now, ZBOS as a routing engine is it's primarily focusing to it's primarily running all the routing protocols like BGP and OSPF, and it learns the route. But FortiOS is not actively participating in the routing. So what will happen is ZBOS will learn the routes. It will populate the routing information base, and then the same information or part of the information will be forwarded to the or will be passed on to forward information base and maintained in the kernel. That is how the 40 OS as the operating system running in the firewall will understand the routing. So other vendors might deploy only ZBOS, or if it's a Linux machine doing routing, it only has to rely on the ZBOS. It don't need to maintain two different tables. But FortiGate, since it has the ZBOS as a route engine, and then the kernel is running in FortiOS, for this reason, now they have to maintain these two different tables. But they will always communicate among themselves, and the informations will be shared. But as an administrator, if you perform advanced troubleshooting in your firewall, you will end up in a scenario where sometimes routes are present in your routing information base, but they are not present in your forwarding information base. Now, this can even lead to outage in your network. So we should be aware about this, and we should know how to check and verify this. I will show you the difference for this in this CLI. So let's check. Now this command, okay, CLI closed. Let's open again. Okay. Now when we run the command get router info routing table detail, the route which we are verifying here, this is actually the a RIB table, that is routing information base. This is what we are referring here. Now, how can we check the FIB table? The command will be get router info kernel. So this will give us the kernel routing table. So let me show it in full screen. You will get some better view. Now, now this is the kernel table, and the one on top is the routing table. So do you see the difference here? So routing table will have only few entries, mostly human readable, easy for us to understand. But kernel, on the other hand, it maintains its own table. Now let's consider this example. Let's say we have this 8.8.8/32, which is pointing towards port 3 and port 4. Now the same route entry is now also available in the kernel table, but do you see how the interface, how the route is maintained? So both of them has the same priority value. So here we can see both of them has the priority value as 1. So it says both of them has priority value 1, and the traffic can come from any source, and it goes to the destination 8.8, and there is no gateway configured. If you remember on the GUI, I never configured the gateway for this. So that is why the preferred gateway here is 00. And the same information comes here. The gateway is 00, and it goes out of port 5, port 3, and port 4. Now, these are the interface IDs. So uh, we discussed in the previous class, like the interface with least ID will have the preference. But again, with ECMP, it changes. We will discuss that later. So what I wanted to show here is the difference between the routing table and the kernel table. Now, kernel table has some additional uh, tables. Let's say this 127 route. This is something which we have not configured in our routing table. If you see, there is no entry for 127 in our routing table. But still in kernel table, we see this particular entry 127.0.0.0. Now, if you remember in the first class, we discussed this, what is this 127 segment? So basically, this is the local interface available on the firewall. So, so if I see there is a local interface available, which are hidden from the GUI, because this is used for different purposes like HA management or 40 40 manager communication. So this is for completely different purpose. So this is the route which we see in our kernel table. Because when the firewall performs the route lookup, or when the 40 OS performs the route lookup, it's not going to refer the routing table. 40 OS will refer the kernel table, and kernel table will or should have the latest information and the best route available here. Now we will check some additional details regarding this when we go through the session. I hope this difference between routing table and fib table is clear for you now. We have already discussed this, but let's check this part once again. So let's see how we can configure a static route on a firewall. So let me delete this. Okay, so how do we create a static route entry in the firewall, and what options do we have? So first thing, a static route is something which is configured manually, but you can also inject a static route either through DHCP or triple PoE, or that is IP or Ethernet. Then you can also inject a static route via VPN tunnels. So if you configure an IPsec tunnel, the IPsec daemon, which is responsible for IPsec, that can also configure a static route in your firewall, but it depends on the configuration. Only if you enable certain options that you will see those routes in your table. But we will discuss those again when we discuss the VPN session that is planned for day 6. Now, basically, first thing you have to mention the subnet. So Ramya has a question on 127.0.0.1 is the loopback route in a router. Does it have the same meaning in FortiGate? So the 127 which we see in the FortiGate firewall is not a loopback IP address. It's not a self pingable IP address or something like that. This 127.0.0 is not even exposed to the other daemons or to the users. So this is only for HA management purpose. So this is hidden away in a separate VDOM. Uh, VDOM we will cover today, hopefully. So this 127 is hidden away in a separate VDOM, and it's used only for firewall's internal communication. You will never see packets going out of the firewall from this IP address. It's only for firewall's own internal communication. This is not exactly the loopback which we see in routers. Okay, so the first and important thing is to specify the subnet. So when we say subnet, it's we refer to the destination. To which destination we are trying to reach. Let's say I'm trying to reach one. I'm trying to create a route for 1.1.1.1, and I should specify the subnet mask, because that is the way we specify a route in our table. So it can be, we can either specify it as /32, or you can also mention 255.255.255. So there are two ways you can configure the destination in the firewall, either by specifying the subnet length or subnet mask. Now, once you specify the route, now the next thing is the destination. The next thing is the gateway address. So if we know the gateway address, we can configure it. But there can be scenarios you have two or more routes, two or more paths to reach the network. And in that scenario, you should have the gateway address configured. If you, let's say, let's discuss what will happen if you don't configure the gateway address. If the gateway address is left to 00, and if we select port, let's say port 3, firewall will try to send the traffic out of port 3. And if it will decide that it has to send the traffic out of port 3, then it will check who's the next stop available on port 3. So it will basically check, does a route lookup to see who's available there, and then it will take the route, and then it will determine the gateway, and then it will send the traffic out. But if you specify the gateway address, then we are basically cutting short one CPU cycle. So if the gateway address is specified, now the firewall will know exactly where to send the traffic based on the route entry. Because if we don't specify the gateway address, then the entry will be 00, and firewall cannot generate destination MAC based on the 00 entry. So it has to go through a recursive route lookup to determine what will be the destination MAC for this gateway, that is traffic leaving port 3, and then it has to fill in the detail. So the best practice is always to mention the gateway address. Now, since the traffic is leaving out of port 3, now is a /30 subnet, so my gateway is 35001. So 35.001. Now, then comes the interface, and once we select the interface, let's say now I know this 35001 is the uh, next stop available on port 3. Now, instead of port 3, let's say if I choose port 4, firewall will detect that the gateway address and the interface address, they are on two different subnets, and this is not the best configuration. It will accept this configuration. This type of configuration is supported only if your network is configured in such a way. So only if 35001 is reachable on port 4, maybe there is some other device, maybe if 46002 and 35002, these segments are in the same L2 switch, it's not best practice, but only if they're connected in such way, this type of configuration is allowed. But if this is not the case, then we should select the proper interface, that is port 3. And then comes the AD. So AD is nothing but administrative distance. Every protocol has its own AD value, which is predefined. But still, as administrators, we can change this value. We can change anywhere from I guess it's from 0 to 255. We can change any values here. But for static route, the default AD is 10, and that is what we see here. And then comes the advanced option, which is priority. So the priority is it's a tiebreaker used by FortiGate, not by other vendors, and it will be useful in scenarios where we have two or more routes with all matching parameters, and still we have to choose one route. So we will discuss priority after some time, but these are the basic details we need for a route entry to be created. Now, let's say to which destinations we will create routes. So let me show the routing table once again. Oh, CLI closed. Okay, let's go here. Now, There are certain, now we discussed about the static route which we created. So this is the static route which we created, that is 1.1/32. But these are the routes which we haven't created manually. But these routes are still available in our routing table. So because basically these are the connected routes. So for every interface that is connected on the firewall, there'll be a route created. Uh, Basically means as an administrators, we don't have to specify a static route for it, and they all come with a connected route. So connected routes will be marked with the prefix C, and static will have the yes. So this is something like you don't if a network is connected to the firewall, then by default they will come to the routing table, and we don't have to manually specify another route here. Now let's say we have a web server. Let's say the web server is abc.com, and currently it's being hosted at an IP address 1.1. Let me go back to Notepad. Let's say we have a website abc.com, and this is hosted in internet, which has the IP address, let's say 180.1.1.1. Now, an user in your organization is requesting access to this IP address, and as an administrator, a firewall administrator, you have to create a firewall policy. And when you create firewall policy, you need to make sure there is a route available. And now, for some reason, maybe for due to some company policy or something, now you are creating a specific route. Let's say 180.0.0.1 is available on port, is reachable via port 3. You have created this manual entry. Now, let's say after 5 days, the administrator of abc.com decides to move the IP address from 180 to 190. Now on the firewall, and now let's say now 190 is reachable via port 4, but there is no route entry created. And your device is still pointing to 180.1.1, and it's going towards port 4. Now, as an administrator, you're not aware that the abc.com has changed from 180 to 190. And for this reason, now the route lookup will fail. Even if it's out of same port, it will fail. Let's say these are /32 subnets. Now, how can we avoid these situations? Uh, Now, this is mostly applicable if you are not allowed to create a static route over your overlay network. Sorry, not overlay, underlay network. So you can end up in a situation where you have overlay and underlay differentiation, and there is no static route or default route pointing towards your underlay, but still you have to allow access to certain websites on your underlay. So how can we do this if the website is keep on changing the IP address? I believe the scenario is clear for everyone here. Now let's go back to the solution part. Let me repeat this once again. Let's say you're an administrator and you are in a situation where you have underlay and overlay differentiation being done in your network, and you're not allowed to create a default route in your underlay. So Faisal has a question, what is underlay and overlay? So Faisal, basically, um, let's say, okay, how do we put this? Okay. So let's say you have site A and then your site B. Now they go through your ISP. So basically, you will have one connection of your WAN link, which connects to your ISP, and this provides your reachability. Now, let's say this is your DC and this is your remote site. You don't want all your all the traffic between these two sites to pass over internet, because anyone in the internet can intercept your traffic. So for this reason, now you will configure an IPsec tunnel to encrypt your traffic. Now, let's say this is IPsec. Now, this IPsec traffic is what we call as an overlay. And this ISP connection is what we call as underlay. So typically, in a network environment, if you are going with this kind of setup, and if you have like hundreds of spoke sites or remote sites, and if you have hub sites, uh, most of the time your internet breakout will not happen over your DC. It varies to organization, but your internet breakout will not happen through your DC. There can be another perimeter firewall which will do it. Now, in this scenario, you cannot configure 0.0.0.0 on your ISP link. For this reason, your default route is not going to work. Now, to bring up this IPsec channel between your site A and site B, you will configure a specific route. Let's say this is 120.1. You will configure route 120.1 on, let's say, port 1. You will configure the specific route for your IPsec channel to come up, and your underlay and overlay will be established. Now, in this scenario, you have to allow connection to 180.1.1. Now, as an administrator, you can create 180.1.1 and you can point it to port 1. But in future, if the website abc.com changes its IP address from 180 to 190, you have to come back to the firewall and create this route, create this new route. This is not always feasible. So we have a solution for this in the FortiGate firewall. So let's log in. So in FortiGate firewall, we have an option, let's say, address objects. So when you create an address object, let's say abc.com, you have an option to create it either as a subnet where you can specify the IP address uh, similar to our example, or you can configure it as an FQDN. So when you configure it as FQDN, you say the FQDN is abc.com, and then you enable this option static route configuration. So once you enable the static route configuration, now you'll be able to refer this particular address object in your routing table or in your static route configuration. So basically what happens in the backend is when you do this type of configuration, firewall will use its own DNS configuration. Let's check what is the DNS configuration in the firewall. So it's using FortiGuard and they are unreachable. So firewall won't be able to reach them. So let's say 8.8. Now I have configured the firewall with the DNS 8.8, and using this DNS, firewall should be able to resolve the FQDN abc.com to an IP address. So if it's a valid website, now you will see the particular IP address being resolved. Let me change this. Instead of ABC, let me say google.com. Now, after some time, in some time, Firewall will resolve this google.com to an IP address. Now, once this resolution is done, you can use this as a object in your static route configuration. So instead of subnet, you will specify your named addresses and you will see the google.com option. Now, if you see here, there's an exclamatory mark which says google.com is not resolved yet. So even though if I enable this now, firewall won't be able to route the traffic because it don't know what to which IP address google.com is being resolved to. So once the DNS issue is resolved, now if I have a specific address, I will be able to route my traffic to google.com using this specific policy. So one moment. Let's check reachability. So destination unreachable. So let me check on the upstream, that is perimeter, whether it has a route. Okay, so okay, uh, let me move it to port 3. Talent. Okay, we will use the perimeter for our testing. Don't have to waste time here. So let me recreate the same on the perimeter firewall. So let's check the perimeters DNS configuration as well. So it should be okay. Perimeter is able to reach the FortiGuard servers, so that should be good. Now let's go back to static route and let's create a static route here. Let's say named address and select google.com. So if you see here now, firewall has resolved google.com to an IP address 142.150.183.142. So now let's say it goes via port 2. Yeah. So since we have used a dynamic address object here, it we get the option to either go with dynamic gateway or specific gateway. So you have the option to choose. If you choose dynamic gateway, this option will be grayed out, and firewall will take care of the gateway address based on the port 2's MAC address entries and next hops. If you specify, you can mention to which gateway address you want to forward the traffic. So let's go with dynamic now, and boom, now the routing entry is created. Now let's check the routing table entry on this firewall. To which address we resolved this to? Google.com resolved to 142.250. So if you check here, you have a static entry created for 142.250.76.46/32. So basically, now as an administrator, now you don't have to check each and every time if the IP address of this website is going to stay the same or it's going to change. So firewall can dynamically resolve the DNS entries and then it can modify this IP address. Now, if we have to dive deep into this, again, there are certain TTL values available in the firewall. So based on the TTL, firewall will keep on checking the resolving the DNS entry to verify if the IP has changed. Now, when we go with these kind of this kind of route configuration, you can end up in another situation where, let's say, you have a PC connected here. Mm, Let's say behind this, you have a PC, and this PC resolves the IP address abc.com, and it resolves this to maybe 210.0.0.1. If this happens, if the PC resolves ABC to 210.com, 210.1, and if your firewall resolves abc.com to, let's say, 180 or 190, these are two different IP addresses. So in this scenario, your traffic will fail because in firewall you have the entry for 180 or 190, but your PC is sending the traffic for 210. If you remember, I use the term the route lookup is done based on the destination address. So if the PC chooses the destination as 210, and if your firewall resolves the IP address to 180 or 190, the destination is not going to match. So we need to make sure, as administrators, we need to make sure that the PC and the firewall resolves the FQDN to the same IP address. So this can easily be done if we configure the same DNS addresses in firewall and FortiGate. So if you have your own internal DNS server, you can easily point the firewall and your host machines to that same DNS, and we can avoid this situation. Now, this situation is very common in enterprise network, so we need to be careful on that. Now, we know. Let me show something. So we know for a fact that uh, Google is not running on a single IP address. Google has multiple IP address. So, but if I go with this FQDN based address objects or route objects, my firewall will only resolve it to one IP address, even though it checks multiple IPs. Let if Okay, I think it will be better if I show you how the firewall resolved this. Just application DNS proxy D8 or 7. Okay. So basically, this is the DNS entries being resolved by the firewall. So if you see here, google.com is being resolved for 142.250 and does a TTL of 5. Oh, what will happen if TTL goes down? Okay, TTL got updated to 282. So by the time the TTL of this domain expires, Google, let me show you that. By the time the TTL of Google expires here, the same will be resolved once again. So this is what I said, that the firewall will keep on checking for any change in the IP address. So the firewall checked once again, and it was able to get this IP address. So if you compare this google.com and this login.windows.net, you see like, there are so many IP addresses being used for login.microsoft.net, and there's only one IP address being used for google.com. It's basically, it has nothing to do with the configuration. It's about the DNS resolution and how the DNS server is being set. So now what I wanted to say is, if DNS, now this ABC, sorry, google.com can have finite number of IP, let's say 5 or 10 IP address. But let's say this is an enterprise network and you have to allow a connection to aws.com. Now, AWS as a cloud service provider, they can have hundreds of or thousands of public IP addresses. And you cannot, maybe you are running a private instance where you have purchased your own IP address, but it will not, if you do a NS lookup for in aws.com, it will not resolve for you. So let me clarify that. Let's say we have a scenario where you are an administrator who wants to allow access to aws.com, and this has thousands of IP addresses, public IP addresses. Now, you cannot manually, it is not possible for you to create routing static routes to all these routing objects. You can use dynamic routing, but how can you, as an administrator, you cannot pair your device with AWS router and learn all the AWS routes. Maybe you are using a 60F or 80F models, lower end series, which has 2 gig RAM. You cannot use that model to pair with AWS via BGP and learn thousands of routes. Your device memory will consume to 100% and your device will go down. So that is not, it's not feasible for us to run dynamic routing in such scenario and learn all the routes. And we can configure static default route, but we are talking about a scenario where you have to create specific routes. You're not allowed to configure static route, default routes, and you have to create specific routes. So in this scenario, now let's say your developers in your network are running a private instance in AWS cloud, and they are using a public address 220.0.0.5. Now this this 220.0.0.5 will not result to aws.com, because aws.com might be running on a different set of IP address, that is, let's say 35001. So your IPs will not match. So if you create a routing object using the address object which we demonstrated, if you use this option, you won't be able to provide access to aws.com. So for such scenario, we have an option called ISDB, Internet Service Database. So in Firewall, if you under policies and objects, you have something called Internet Service Database. So these are nothing but well-defined, predefined address objects or internet services, which basically has the IP address of all the entries. Let's say if I search for AWS, I have Amazon AWS, which has 26,751 IP addresses. So now, who created or how this 26,751 IP addresses are being managed? So Firewall gets its periodic updates from FortiGuard. So FortiGuard is a server that is maintained by Fortinet, and they periodically query or they create a database of what kind of public services or public servers are running and where can we club them or group them together. So if you are running a EC2 instance on AWS, and most probably you will get an IP address from this 4,878 objects. Now, if your developer, let's say your your developers or any of your employees are asking you access to a specific EC2 instance, you don't have to allow access to entire AWS, because there are scenarios where malicious actors or hackers are present in AWS. They have their servers in AWS. And if you allow connection to entire AWS in your policy, and they can use that policy to come into your network. They can piggyback on any of your existing connection, and they can use that to access your internal service. So we don't want that. So always we have to create specific policies. We have to create specific routes. So for those scenarios, we have these address objects, internet service database created in the firewall. So if I have to allow access to an EC2 instance, I will be referring this EC2 instance in my policy. So it refers to specific routes. Now, if I have to allow an S3 bucket, now I will use this S3 object. So now only an S3 bucket is allowed in the policy or in the routing table. So similar way, you have lot of other ISDBs. So for example, we even have Microsoft. So in Microsoft, you have Azure, you have your um, Outlook servers or your Azure applications like Word, Skype, they all have their own address objects. Now, if you check Microsoft's website, they have a list of IP address blocks, which they mentioned that those are the only IP address in which the Skype Teams application will run. So this is a publicly available information. Now, FortiGuard or Fortinet will get this information, and then they will build up this table. They will maintain this entry. Now, you can also create your own ISDB or geography based objects for a specific service, because there can be situations, maybe your IP address is not available in this list, it's available in a different list. You have to modify this. So all this is possible in FortiGate Firewall. But I just wanted to give this clarity that to come across this situation where Google resolves to couple of IP addresses and then you want to allow some other IP or service, you can always use this ISDB. So when you create a static route, instead of named addresses, you specify the internet service, and then from the list available, you will select which service you want to allow. Let's say I want to allow Zoom. Let's see if I have Zoom available. So I have Zoom meeting available. So Zoom has 1718 IP address, sorry, 4,83,000 IP addresses, and it has the 1718 ranges. So now I don't have to mention these IP addresses and ranges manually. So all these are being done in the backend, and I just need to point a route. Now, now let's say how this routing table will look like in this scenario. So I have two static entries, but these are not for Zoom. These are for google.com, because Google now got resolved to two different IP address. So I have those two different IP addresses here. But where did my zoom.com went? I don't have an entry for zoom.com now. Now without an entry, how will I route the traffic? So I believe like you got the scenario here. So when I created an address or a route based on the named addresses, I have the specified entry in my routing table. But when I used an ISDB, Internet Service Object, I'm not able to view those routes in my routing table. So without the entry in my routing table, how will the routing works? So this is where the fib table gets in. Now there should be an entry here, which should be more like a policy route entry. Now I can verify this from one more place, that is dashboard. So if I come to my network under dashboards network, and if I select my policy routes, this is where we will see. One moment. Policy should not say this. Okay, there should be an entry coming up in the policy route table for our Zoom traffic. Okay, which firewall did I configure this? One moment. Okay, Zoom is configured here. Okay, I think this is a bug or something, because this route, the source should not be all. It should be zoom.com. So I think this is a bug. Uh, What's the FortiOS 744? Okay. So basically what will happen is your policy routes the ISDB objects which we configure will not reflect in the routing table because they will be considered as a policy route. Now policy route will take precedence over the routing table, and so policy route will have a direct entry here in the kernel as well. It should have. Let me check. This is for the default route. Okay, for some reason, the policy route is not learned on the kernel also. So this is clearly a bug. So what happens is whenever we create a policy route, the policy route will take precedence over the routing lookup. So when the in the order of events, this will you will have better clarity when we go through the life of the packet. So in the order of events, before going for the route lookup, there will be a policy route lookup happening. So whatever ISDB based objects which we configure in the firewall, it will be considered as a policy route in the firewall, and that policy route will be available here. Now we have this route. If you see, it's pointing to port 4. That is where we pointed the Zoom object to. But instead of specifying Zoom as a source, Zoom as the destination, it specified all destinations. That is 000. So this is wrong. Okay, so since we are in the route and monitor, let's take a look at here as well. Now, we know that we can verify the routing entries from our routing table in CLI and then the kernel table. Money has a question. Can you explain the AWS part again? Okay, sure, Money. So let's assume a scenario here. Let me clear this. Let's assume a scenario where you have your developers in your network. They have their servers deployed in AWS. So they can have their instances, then S3 buckets, everything running in AWS. Now, if you're familiar with cloud networking or mm, any cloud, let it be AWS or Azure, they will allow you to bind or purchase a public IP and use it for your service. Let's say now your developers are running an instance. Let's say this is a server, app server running in AWS, and this is running on 180.0.0.1. For example, let's assume this. Your developers have purchased a AWS service. They are running an app server instance with a public IP address 180.0.0.1. And they have an S3 memory bucket. This is again running in 190.0.0.1. You have paid for these two IP address and you have got this IP address from AWS. Now, earlier in the firewall, we discussed this option to create a static route by using the address objects. So where you can specify an object, which in our example, we considered google.com. Where did I do that? Okay, here it is. So in our example, we created this address object google.com, and then we used this google.com in our static route. So here we got two IP addresses for this. Now, similarly, let's say I create another object. So let's say I believe aws.com is the domain. aws.com. Let's check. Okay, aws.amazon.com. So let's say I have a domain aws.amazon.com. Okay, this is sorry, FQDN. aws.amazon.com. Now I have this entry created, and if I come back to my static route configuration and I create this route, it says AWS. Did we apply that? FQDN. Okay, I forgot to enable the static route configuration. So that is the reason why when I try to create a static route, I didn't get this AWS being listed here. So let me go back and enable. So in this object, let me say this is a static route configuration and come back to static route, and I'm trying to create an address object based on name addresses, and I choose AWS here. So let's say port 3. Now I have this particular object and it resolves to one set of IP address that is in the range of 18.67. Now, interesting thing, these 18.67 IP addresses, they refer to the aws.amazon.com website. These are not referring to the um, actual S3 instances or your any VM instances which are running in your AWS. Or in short, let me go back here. In short, uh, these IP addresses, those IP addresses in the range of 18.1, they all will point to. Sorry, where did I get this? Yeah. So these IP addresses 18.67, they all were pointing to aws.amazon.com. This is not pointing to your actual service that is 180.1 or 190.1. This is a problem. For this reason, we won't be able to use these kind of address objects. So what we can do is, instead of using this address objects to resolve for aws.amazon.com, we can use ISDB objects. So if I go to ISDB, in ISDB, I have AWS service. And if I have to allow connection to my EC2 instance, this EC2 instance will have all these IP addresses and services. Now, 99% we can be sure that whatever instance you purchase will get an IP address which is available in this range. So now you will find your IP address in whatever IP address which you have purchased from AWS, you will find that IP address in this list. So now you can directly refer this ISDB in your firewall in your static route, and you can use it to route your connection to AWS. Now, by this way, you're not exposing your network to the entire AWS, because anyone in the AWS can then access your network by piggybacking on your existing connection, and it will compromise your network. For this reason, now we have ISDBs, and in ISDBs, you have specific entries depending on your need. So you have to you should not generalize your uh, selection. You need to make sure exactly which service you want to allow in AWS. You have a lot of services in AWS. Maybe you only for certain API request, maybe your internal servers, your internal application servers have to communicate with AWS. In that way, in that scenario, you will only allow your API gateway communication. You will not your other EC2 instances or your S3 buckets or anything else to communicate. So you have certain level of granular control here. So this is what I was referring to. I hope that part is clear, Money. Please respond back in chat. Okay, perfect, Money. So let's move on. Okay, so now we know like how to check a route from the CLI by checking the routing table and kernel table. Now, if you're not comfortable with the CLI, we always can come to the dashboard and you have your option from GUI to check all the routing entries here. So Money has a follow-up question. So as per my understanding, we can specify services by using the IP address or permission. Yes, Money. Now what you can do is now since you have defined your policy, if you remember, I used a term that the security policy should be configured based on the routing which you have in your firewall or in your network. So if your routing says for AWS you have to go out of port 3, now you can specify your firewall policy saying that if I want to communicate to an EC2 instance in Amazon, I have to go via port 3. So that way you have some control. Okay, perfect, Money. So in Route Monitor, you can check all the routes which is available. So basically, whatever route we have in our GUI, the same entries are available here in our GUI as well. So you can select the a static or dynamic entry. So if anyone is feeling confused where this 18 came from, these are for AWS. So we just created an AWS based address for to answer Money's question, and that is where these entries 18 are coming from. And this 142 entries are coming from that Google object which we created. So now what options we have? So from GUI we can check the network. So network is the destination which we are trying to access. So all the routes that are being learned, all the destinations which we have learned, everything will be listed here and their corresponding gateway addresses and the egress interface along with the distance. So now if you check here, uh, the distance is what we are referring to AD value. Now, if you remember, the default AD value for static route is 10, but this particular static route is learned with an AD value of 5. So any ideas why we have this ADS 5 for this particular static route? If anyone wants to answer, feel free to answer this in chat. Uh, Money shortest path to route. No, AD is something that is fixed. So let me clarify also. So for static route, the AD is 10. Now, similarly, for BGP, that is EBGP, we have the AD of 20, I guess. So for OSPF, again, there is an AD value. I don't remember it top of my head, but I think it's 110. I'm not 100 exactly sure. So every protocol has their own AD value, and for static route, the default AD value is 10. But still, here we see the AD value as 5. So Lakshmi Narayanan said when we have two static routes, we reduce the AD value. So let's check. Let's check. Did I created a static route in the GUI? So I haven't created a static route for 000, which is pointing with AD value of 5 in my routing table. So where did this route come from? So, and this, interestingly, this route is pointing to port 2. So let's see what configuration we have in our port 2. So Vignesh, you cast it. So port 2, we are receiving the IP address from DHCP. So this, for port 2, this firewall is acting as a DHCP client, and we are receiving this route from DHCP server. And when we receive the DHCP server, we configure the distance. By default, it's set to 5, but if we want, we can change it. It got the distance set to 5. So we are receiving a static default route from our DHCP server, and that is the reason why we see this AD as 5 for this default route. It says it's a static default route, but it says it's static, but I haven't configured it in the static route section. But through DHCP, we have learned this route, and that is why we see in our dashboard this particular AD as 5. Now, if we receive the same route from IPsec VPN, we will see the AD value as 15. So if I am, interestingly, let me show it real quick. If I have to configure a IPsec VPN, let's say test. I'm not going through the entire configuration part, but let me show it real quick. So in IPsec, we have an option which says add route. So if the add route option is enabled, and if I specify the subnet, the remote subnet as 000, then it will create another default route, that is 000, in my routing table with the AD of 15. That 15 is coming from, the 15 is actually coming from your IPsec VPN configuration. So just keep this in mind. It will be useful in some scenarios. So it will also show the type of route. So if it's a route, the route is static, so we will see all the static routes. If it's a connected route directly connected on the interface, we will have them tagged as connected. So what other options which we have here? So similar now, if you click on this little wheel button, you can enable all the other metrics or other tiebreakers. So I can enable metric, I can origin, priority, VRF. So let's check all this option. Now, metric is something which is specific to a routing protocol. So since most of our discussion in today's session is related to static route, we see the metric as 0 because static route doesn't have a metric. Let's say if two different routes are learned from same routing protocol, and if they have same length, then how do I put this? Two different routes are learned from same routing protocol. If they have a same length, then this metric will be used to choose the best route. So let's say I have a subnet 192.168.10.0/24. I am learning this from OSPF, or let's say BGP, but I am learning this from two peers. The first peer is, let's say, 10.1, and the second peer is 20.1. Both of them are eBGP. So their AD will be 20. So now in this scenario, if you check, now your prefix, your length, your network length is the same, 192.168.10.0/24. Both of them are being learned from eBGP with the same AD20, but still you wanted to choose one of them as best. So in this case, your metric will come in. Now, in case of BGP, the the metric selection or the best route selection, there is a 11 steps and two tiebreakers. So that's a different thing. But for some reason, let's say if we are using metric as a tiebreaker in BGP route selection, and if this route comes with the metric of 200 and this route comes with a metric of 100, then the lowest metric will be selected as the best route. So what I wanted to say here is only if the routes are learned from same routing protocol, and if you have to choose a best from that, then you will come back to metric. If the comparison is between two different routing protocols, then you will go back to AD. So if the comparison is between two different protocols, we will use AD to select route, administrative distance to select route. But if the comparison is between a route coming from same routing protocol, then we will use metric to choose our best route. So if I am using one moment. So in our scenario, we are not using dynamic routing protocol. That is the reason why our metric is all zero. But if I use BGP or OSPF, then I will see the corresponding metric values populated here. Now, origin, where we are learning this from. So since the first default route is coming from DHCP, we see the origin as DHCP. But if you learn it from OSPF or BGP, you will see those values being specified here. But now these are all static routes. It simply point them as unspecified. So Vignesh has a question. Metric is same as cost again. So cost has a different definition. So we will discuss this later, Vignesh. So cost is something which is used. It's calculated differently. So we will come back to that discussion later. Now priority is something that is specific to FortiGate. So priority is where uh, let's say now BGP or OSPF having their own route selection algorithms, you use them to select the best route. Still, if you wanted to influence any of those entries, then you will use priority. So in FortiGate firewall, the route with the lowest priority will be used. So let's see if I head back to static routes. Okay, I think I have it configured here. Let me check. Network. Okay, now I have this 000 default route which is pointing to port 3. Now let me create one more route and let me point it to port 4. And in advanced, let me have the same AD. The AD is still 10 for both the routes. And let's see the priority which I set is 5 here. So routes with a larger value will have a lower priority. So if I set the priority to 5 here, now my route towards port 4 will have least precedence and route towards port 3 will have better precedence. So if I wanted to influence again this route selection, in that scenario, we will use the priority. So Nagaraj has a question, same AD, it will load balance the traffic. So if ECMP is enabled, yes, it will load balance, but it has to meet some other criteria as well to perform the load balancing. Uh, I have it in the plan for the day. So if time permits, we will discuss ECMP also. Okay, there's some more thing I want to show about this dashboard. So we see this static routes which are manually created, and then we see the connected routes for all the interface assigned. And then you will also see one more type dynamic, which is for the routing protocols, routes learned from routing protocols. Now, there are certain routes which you will not see here. For example, inactive routes. So let's check that entry here on this device. Let me show you. So I have the route for port 4, but I don't see the route for port 3. Port 3 has the better priority, I guess. Let me check. What happened? Network. So I have two routes configured. One is via port 3, which has a AD and the priority is set to 1. Oh, okay. The AD is set to 15. Okay. This is why. Let me configure it back to 10. Now let's go back to the dashboard. So I have two different routes. One is via port 3 and the another is via port 4. So both of them are to the same destination. They have the same administrative distance value. And let me enable the priority and let's check. The priority for these two routes are 1 and 5 respectively. And both these routes are now currently present in the routing table. Now both of them are active routes. Now let's say now the interface port 4 is going down. So if the interface port 4 goes down, then the route over the interface port 4 that will become inactive, and the inactive route will be removed from your routing table. So you will not see any route that is pointing towards port 4 in your routing table because that route is being marked as inactive because the interface is down. So let me enable it back. And now you will see those routes pointing towards port 4 in our routing table. So I can filter and show it as well. Like there are like two routes on port 4. So if port 4 goes down, these two routes will be removed from the routing table because they are inactive. Now there is another scenario where we will not see the routes. Let's come back to the same default route. Let me mark the route towards port 4 with a higher AD. Now let's say this is AD 15. Now if I go back to the monitor tab, again I will not see the route which is going over port 4. The default route is only present for port 3. It is not present for port 4. The reason being port 4 is the route on port 4 is same as the port 3, and the only difference is the AD is high. So it is a duplicate route with a higher distance. So anyway, we are not going to choose it as a best. If I come back to the routing table, what happened to the CLI on this? Let's go from here. So let's say if on the remote firewall, if we verify from the CLI, so I have only one route that is pointing towards port 3 for default, and that is because of the AD10. But if I check the routing table database, I see two entries here now. So only the best route now selected, and the best route will be available in your GUI monitors or in your FIP table. So the routing database is a collection of all the routes, whether it's a best or non-best route. Everything will be available in the database. And if you see here, you see this AD15 route as well, but since it's not being considered as best, you're not seeing this AD15 route in your routing table or in your RIB information, that is routing information base. And if the route is not available in the routing information base, it will not go to your forward information base. So only this particular route with AD10 will be sent to your kernel, and the route with 15 will not send will not be sent to the kernel. So let's verify the kernel route also. So in kernel route, you will only see the default route pointing towards port 3. You will not see the route pointing towards port 4 because port 4 has a higher AD. Because of this reason, it's not considered a best route. Only if the route is considered best, that route will move from your database table to your routing information table, that is RIB table. And only if the route is present in your RIB table, it will be injected into your kernel table, that is your FortiOS table. So these are the two scenarios in which you will not see a certain route in your GUI monitor tab. So if you choose to use your monitor GUI to verify your routes, please keep this in mind. Like these are the two situations where you will not see a certain route in your in the GUI. I hope that part was clear. So I said earlier, so if you create a ISDB policy or let's say you create a SD-WAN rule, where is SD-WAN? So network and if you create an SD-WAN rule, uh, that will also be shown under the policy tab. Or let me do one thing. Let me create a policy route here. Let's say from source as uh, incoming interface. No, I'm showing creating this to show you a scenario. So please bear with me for a minute. Not all. Let's say I will say okay, AWS. So forward traffic to gateway, outgoing interface, and port 3. Now I have created a policy route in the firewall, and now where will this policy route can be seen? So if I check from the this is dot two, okay, perimeter firewall. I have created a policy route, and this policy route will not be available in the routing table. Not sure what happened to the CLA out of sudden. Let's close it and opening another session. Let me do a quick cleanup here. Static route. Let me delete this AWS because it's confusing us. Then let me delete this Google and this Zoom. Okay. So now we have a policy route being configured in the firewall, and that policy route is actually pointing to AWS. So I don't see this policy route in my routing database, but it should be available in the kernel table. So let's validate the kernel table. So if I check my kernel table, I should see a route pointing towards port 3 in my kernel. So where is port 3? Surprisingly, we don't see any route towards port 3. What's happening with the policy route today? We don't see any of those policy routes being injected. Check from GUI. So network. Okay. So if from kernel, I'm not able to verify, but if you see now I have a specific route which is pointing towards AWS, and it's available in my GUI monitor. Now you have this drop down option where you can see static and dynamic. So you will not see even though we have a policy route available, which is a normal route. It is not available in your static dynamic table because policy route is a separate database being maintained, and this policy route lookup will happen prior to your regular route lookup. Now, the reason why the policy lookup will happen prior to your regular route lookup is it has something to do with the creation, because when if you check here, when you create a policy route, you can take some decisive action on that. You can forward the traffic to a completely different interface, or you can stop forwarding your traffic. So for because of this action category, because you can do a decisive action based on the policy route, these routes are normally not present in your routing table. Instead, a separate table is being maintained, and that table can be verified. That table can be viewed from your GUI under the dashboard monitor, and here you have to select your policy route, and then you will see all your policy routes here. Now, the tiebreakers for any route. Okay, how a best route is selected? I'm sure you are aware how a best route is selected. So for a best route to be selected, the first thing is the longest prefix match. Uh, We are almost on time now. So the first criteria for a best route is your longest prefix match, and second is your AD, and then third is your metric. So this is exactly what the tiebreaker will also be. So if you have to choose between two different routes, then you will make sure that they have the longest prefix match. For example, if I have an entry 192.168.00/16, which is pointing to port 3, and then I have another entry 192.168.0.10/32, and this points to port 4. Now, if there is a packet coming on the firewall which has the destination IP as .10, 192.168.0.10, now based on the route lookup, it will use the longest prefix match, that is /32 is the longest match here. So it will use port 4 to forward your traffic. Now, this is a tiebreaker situation when you have two routes which is matching your destination, and which one to choose from it. So it used the longest prefix match to choose the port 4 traffic, port 4 as your routing interface. Now let's say if both of these entries are pointing to port 4 and both of them are saying 10 and sorry, both of them have the same length, but they are two different interface. Now, which one to choose from this? Which route to choose from this? Now, this is where the AD will come from. So if this has the AD of 10 and this has the AD of 20, now the traffic will leave out of port 3 because of the lowest AD. And it will choose your, port 3. Now, if for some reason, if you have configured both the routes with same AD, then it will come to metric. Now, for a static route, the metric is 0, so it's not applicable. But if it's a dynamic routing protocol, if it's OSPF or BGP, then the metric will come from two different places. For example, in OSPF, the metric will come from link bandwidth calculation. And in OSPF, we refer this as cost. And if it's BGP, the metric will come from a BGP attribute, that is med. So this med will refer to the metric in BGP attributes. So if the routing, now in this scenario, we can use metric. So let's say if instead of static, if I learned this from, let me track this here. Now let's say I learned this from OSPF, and this route we learned from same OSPF. Now they can have a same metric. If let's say, sorry, let's say if the metric for this is 50 and if the metric for this is 60. Now based on this, now these protocol, now if you pay attention here, both of them have the same length, the destination has the same length. The AD will be 110, I guess, for OSPF. And then the metric is saying 50 and 60, but they are from the same protocol. So only if the routes are learned from same routing protocol, OSPF, metric will be compared. And between 50 and 60, again, the lowest will be chosen and 50 will be selected. Now, let's say if this is coming from BGP, now the AD for this will change. So instead of 20, sorry, instead of 110, the AD for BGP will be 20. That is, eBGP will be 20. Now it will not even go to check the metric. The tiebreaker will be decided here in the AD itself, the second stage where the lowest AD is preferred and BGP route will be chosen. So this is how a best route is being chosen in a firewall or in any L3 device. But along with this, now if you're learning a route from OSPF or BGP, you don't have this option. You're influencing your route selection influence will all happen in your protocol level. But if you choose to use your static routes, there is a situation where your network length will match, your AD will match, your metric will match. That is zero. Metric for a static route is zero. So, but still, if you want to influence, you have to use the option of priority. This is where the priority will comes in. So priority is an option which is only available in FortiGate. Other vendors might use some different option, but for dynamic protocols, the influence will always happen on the protocol level. We have exceeded our time here. I still have a lot of other topics to discuss for the day. Unfortunately, we ran short on time. So there are concepts like reverse path forwarding and then ECMP and difference between ECMP and SD-WAN, how the ECMP load balancing will work, these topics which I have prepared for the day. So let's move these topics to our course and we will discuss it there. And I will also include some more labs. I think today's session is mostly focused on the theory part. We didn't get a chance to do much of the lab for this. But during our full course, I will build a complete set of lab and we will spend more time on this routing. Now I will leave the maybe another 5 minutes time to answer the question and answers. So please feel free to ask your questions in the chat. I will answer those.